So let's say there you have a product of two functions. Let's say f of x times g of x. All right, where f of x could be anything in terms of x, and g of x could be anything in terms of x. And you're asked to find the derivative of this product, right? So you're asked to find dx of this. Well, how do you go about doing something like that? Well, there's a general rule you will want to follow. No, we're not going to prove the rule from first principle, but you could just apply the generalized formula. There's the generalized formula if you want. So what you would do is first you could hold the first function, right? So you could say f, right? F, right? The function remain itself. Whatever this function is, you just write it back, right? So it's equal to f times the derivative of g of x, and then you plus the derivative of f of x times g of x. So essentially, if you notice, right, it's just adding, two product, right? Where the first product, you hold one of the function and differentiate the other. Then you add that to the differential of the other function times the other function. So look here, I'm not differentiating f of x here. I'm not differentiating f here, but I'm differentiating f here. I'm differentiating g here. I'm not differentiating g here. So essentially, we want to do is a sum of two product, right? Where you basically alternate the one that you differentiate in a sense. That makes sense. So if you have to differentiate this here, you basically would find ddx, or in this term, it would be f of x times ddx, right? Because I'm differentiating g of x, right? Plus. So now I would have to differentiate. f of x, and then I times that by g of x, right? Which is basically what I have here, simplified, right? You also would find that some people would write it in terms of u and v, where the products are u and v instead of a function. So let's say you have a product u times v, and you need to differentiate u and v. And let's say that u and v are a function of x, right? So I'm differentiate with respect to x. You'd find that the same thing is going to be u times v prime plus u prime times v, right? It's the same thing. You differentiate your whole one, you differentiate the other one, then you plus it and you alternate it. Then you differentiate it now, you differentiate u now, and then you multiply it by v. So let's apply this rule to something. Let's say that we have let's say that, I don't know, y is equal to x squared, right? So let's say maybe this here times sine x, right? So you could think of this as maybe it's two separate functions. Yeah, you could think of this as u, you can think of this as v if you want to. So how do we differentiate it? How do we find dx of y, right? ddx of y. Well, we say that to find ddx of y, which is actually ddx of this entire thing here, x squared times sine x, is that first we hold the first product, if you want to say. We hold the first term of the product, which is x squared, right? Oh, as a matter of fact, you could switch this around as well. You could put this at the front and at the back. It doesn't really matter. Addition is commutative, right? So if you want to differentiate this first and times it by g, right? And then do f times the differential of g, that's okay as well. So you could switch this around. It doesn't really matter, right? You could switch this around. So this is gonna be times, I need to differentiate this one here. So it's gonna be dx of sine x, right? I'm just gonna write it out fully so you could see. And then you have, well, I'm gonna differentiate the other term now, which is this term. I'm gonna have to differentiate x squared. Then I'm gonna times it by sine x, right? So this is gonna equal to x squared. When I differentiate sine, what do I have cos x, right? Plus, I have to differentiate this here now. So it's gonna give me 2x times sine x, right? So this here is your answer. Maybe you could factor out a like term. A like term here would be x. So this would give me x cos x plus 2 sine x. Right? So this here would be answer. All right. So to simplify this, you could have just say, hey, it's just the differentiate this. So you could say u times v prime plus u prime v, right? You could have just done that and just plug in stuff. You don't have to rewrite these here. You don't have to do that. But this is just the general operation what you're doing, right? So if you're in an exam and you don't have to, you don't have to write back all of these here. You could just do this and straight away and get your answer faster. Okay. So let me see if I could. Let's see the next example. Let's say y is equal to x. In this case, let's say x sine x. How do I do this? Well, the y dx, right? So I'm differentiating y is just equal to x. This is u plus v. So this is equal to well, the different. If I differentiate this, is just equal to u. Let me write it here. U times v, where this is u and this is v, plus u v, right? So this is equal to x whole x, and then I differentiate this. So if I differentiate this, I would get cos x plus I differentiate this. If I differentiate x with respect to x, I just get 1, and then this here whole is a sine, so I have this here, right? So x cos x plus sine x.